Okay, there's one last situation I want to look at, and that is if we had something like this. So example 3, I'll do a B example for this also. But example 3, let's graph y equals the square root of 9x plus 18. Okay, there's a couple different ways we could do this. Seeing this number in front of our x is something that we hadn't actually worked with yet this year. And I think some of you guys have kind of thought through what this would be already. Maybe some of you haven't. If you look back at, yes, let's see, one that you guys all did, example 1a, where I had this 2 in front, that was a vertical stretch. Multiplied on the outside is a vertical stretch. So let's think about if I'm multiplying something on the inside by 9. Inside is horizontal. Remember that everything on the inside does the opposite of what we think. This is going to be a horizontal compression, meaning our graph would get shrunk in horizontally. It's going to get moved closer to the y-axis. And that's not always the easiest thing to graph. There is a different way that we could graph this, instead of actually working through what the horizontal compression would do to each of those points. And that's a little bit easier to do. So what I want to do instead is notice, hey, this 9 and this 18, I can divide them both by 9. I can factor out a 9. So instead of thinking of this as the square root of 9x plus 18, let's think of this as the square root of 9 times x plus 2. And this, well, that's the same thing as the square root of 9 times the square root of x plus 2. And that's going to make our lives a lot easier, because then instead of thinking of this as a horizontal compression, square root of 9 is 3 times x plus 2. We can think of this as instead a vertical stretch. Vertical stretch, and then this plus 2 underneath moves left 2. That's going to be a lot easier for us to graph than this horizontal compression and left 18. This is a lot easier for us to graph. So I'm going to graph that right here. It's a square root again. My parent function, 0, 0, 1, 1, 4, 2, 9, 3. Here's my parent function. Take each point, move it left 2, and then our vertical stretch makes us multiply our y value by 3. Left 2, multiply your y value by 3. Left 2, y value times 3, so my y value becomes 6 now. And then over here, left 2, multiply my y value by 3, brings us all the way up to 9 here. So we're really, really stretched out. Again, that makes our graph a lot easier, our function a lot easier to graph, instead of moving left 18 and then our horizontal compression by 9.